Hi, I'm Hasna Wakrim, a PhD student at the University Hassan Casablanca, Morocco. In this presentation, we will talk about the performance of carbon-coated NVP in ionic liquid hybrid electrolyte. So, compared to the lithium-ion battery, the sodium-ion battery is considered as an expensive alternative energy storage system due to the large abundance and low cost of sodium raw compared to lithium, their chemical property which is close to lithium, and also fast charging. The sodium-ion battery, in a simple way, is composed of an anode cathode separated by an electrolyte, where the electrolyte is the key element of good work of battery, which is responsible of sodium-ion mobility. Generally, the liquid electrolyte based of carbonate solvent are the most used due to their high ionic conductivity, low viscosity, electrochemical stability, and easy to prepare. But on the other hand, these electrolytes suffer from their high flammability, toxicity, and thermochemical instability, and their decomposition, which allow to form of unstable layer solid electrolyte interface onto the electrode, which reduces the safety and electrochemical performance of battery. So, as solution, some additive can be used. In our study, we have used ionic liquid as additive. So, what means ionic liquid? Ionic liquid are organic salts with a melting point below 100 degrees Celsius and are composed of big organic cation, which is responsible of decrease of melting point, and inorganic or organic anion. And compared to the carbonate solvent, the ionic liquids are no flammable and thermal stable, and also show no volatility property, and have a high electrochemical window with high ionic conductivity. In our study, we have synthesis or ionic liquid by two steps. The first step is based on alkylation reaction to obtain the zero cation with halogenated anion. The second step is the metathese reaction, which allows to change the bromide anion with the hexafluorophosphoric anion to get a hydrophobic property. Then we prepared our electrolyte by mixing propylene carbonate with sodium thiopside salt, and we added 10% by weight of prepared ionic liquid. As expected, the prepared ionic liquid showed a good thermal stability and discharge decomposition at about 300 degrees Celsius, and compared to the propylene carbonate, the ionic liquid was unflammable. And when it was added to the net electrolyte, a significant increase in the thermal property of electrolytes have been observed. Then after, we prepared a coated carbon NVP by a solvent method, and we studied its electrochemical behavior in the hybrid electrolyte based in ionic liquid and in the net electrolyte. So as we can see in the charge-discharge curve, the cathode will have an excellent cycling performance in the ionic liquid electrolyte and exhibit a reversible first discharge capacity of 123, which was higher than this obtained for the net electrolyte. Also, the NVP cathode have exhibited a high Coulombic efficiency up to 90% and show a reversible capacity and stable cycling after 30 cycles, with the formation of a large plateau between 323 volts and 325 volts, which correspond to the redox reaction of vanadium ion. So, to investigate the reason of the increase of cycling performance in ionic liquid, non-petals measurement was realized, as we can see that the addition of 10% of ionic liquid to the net electrolyte have significantly decreased the real resistance of the net electrolyte, and that means that the ionic conductivity of electrolytes have been improved, which means that the mobility of sodium ion was increased by the presence of ion species of ionic liquid. So we conclude that addition just of 10% of ionic liquid have significantly increased the electrochemical property of the carbon-coated NVP half cell, and thank you for your attention.